Hello, 7th graders. We are in section 5.2, which is over relations and functions. Now we're going to start off with a few vocab words before we go into anything else. The first vocab word is called a function. A function is a relationship that assigns exactly one output, which usually is a y value, also called your range, for each input, which is your domain or your x value. So for example, if I gave you these three ordered pairs, the 1, 2, and 4 would be the inputs, which are your domains. The 2, 3, and 7 are your outputs, which are the range. Every input has one output. So 1 has an output of 2, 2 has an output of 3. So this would be a function. If I added in one more, and you got that, how many outputs are there for the number 4? If you plugged in 4, you actually are getting 2 outputs. So therefore, 4 having 2 outputs, this would not be a function because you have two outputs for only one input. And a function is when you only have one output for each input. The second vocab word is called a relation. A relation is a set of ordered pairs. So for example, if you look at the chart below where it says giraffes, where we compare age and years, the ordered pairs below form a relation, and that relation represents this: age and height. Now, you can list these ordered pairs in a relation. So if we're using a relation, we're going to use braces. The braces kind of look like this. So in that brace, we're going to list the ordered pairs. In this case, 18 and 4 1/4 meters. And then 20, 4.40, and we keep going. And therefore, we have a relation with those 5 ordered pairs. Now, if you remember, look at above. A function, once again, assigns exactly one output, which is your range, for each input. One way that you can tell if a relation is a function is by making something called a mapping diagram. You're going to list the domain values and the range values in order. Then you're going to draw arrows from the domain values to their range values. So in part A, in example 1, we're going to determine whether each relation is a function. So in example A, you can see there's a relation between those 4 ordered pairs. A mapping diagram is when you write your domain and range. And then we're going to list them in order. So usually you put them in like a little box-shaped thing. So 11, 12, 13, and 20. Now in your range, we're going to put them in order: -2, -1, and 7. Notice that I did not repeat -2 since it appears more than once. I don't write it more than once. We only need to write it once. So 11 goes to -2. 12 goes to -1. 13 goes to -2. And 20 goes to 7. So this is where it gets a little complicated because you may think, oh, this is not a function. Remember, a function is where you have only one output for every input. Now, how many outputs does 11 have? Only one. How many outputs does 12 have? Only one. How many outputs does 13 have? Only one. How many outputs does 20 have? Only one. Therefore, there is no value in the domain that corresponds to more than one value in the range. So this example is a function. Now in example B, I'm just going to go ahead and write your domain and range down. And let's say after our ordered pairs, we write them in our domain and range. And our domains, we have -2, -1, and 6. And then in your range, we have negative 1, 0, 1, and 3. Now, negative 2, let's say, goes to negative 1. Negative 2 goes to positive 1. Negative 1 goes to 0, and 6 goes to 3. So your order pairs will look something like this. Now, in this example, negative 2 has how many outputs? The domain negative 2 corresponds to 2 outputs. So we have two values for the two output values for the input. Therefore, this one is not a function. Now, another way that you can tell whether a relation is a function is to analyze the graph of a relation. So we can graph all of our points, and then we're going to use something called the vertical line test. If any vertical line passes through any more than one point on the graph, then for any value of x, there is one more value of y, therefore the relation is not a function. So I'll say that again. If any vertical line passes through more than one point of the graph, then for some value of x, there is more than one value of y. Therefore, the relation is not a function. So this one, you don't need to actually write down because it's pretty easy and you don't need to take the time to write the graph down. This is on page, in your book, if you wanted to look, this is on page 258. So vertical line test. So what we start off with, whoops, let me get rid of that. That's not what I wanted to do. So we have a vertical line. There we go. So I'm going to use this. And I'm going to move it. So graph the ordered pairs, we did that. Pass a vertical line across the graph. So we go across. Oh, there it crosses once. There it crosses once. Crosses once. Crosses once. Crosses once. Therefore, this example here would be a function. But let's say I threw in one more point. And I started moving the vertical line again. So it crosses once right here. Bam. How many times does the vertical line cross those points? It crosses twice. Therefore, this would not be a function. And it can be the same thing if you actually had a shape. So let's say I had a line. Is this vertical line ever going to cross this graph more than once? No. So that's okay. This would be a function. But this is what's called the vertical line test. Now, a function rule is just an equation that describes a function. Now, you may have heard this, you may have not, but there's something called a function machine. Here's what it kind of looks like. And I remember this being drawn to me when I was a kid. And this is a really, really, really bad drawing. But this goes in, this comes out. This is your machine. This is your function rule or your equation. Your input, which is called your domain, is what gets plugged in. Your output, which is your range, is what comes out. So for example, if I gave you an input, which usually we call x and y, and your y is output, if I did 1, 2, and 3, and my outputs are 7, 10, and 13, what function rule or what equation would you write with that? You would write y equals, now if you don't know how to get this, your y's increased by 3 as your x increases by 1, therefore my function rule is going to start with 3x. And if you multiply each of these by 3, 1 times 3, you can only get 3. 2 times 3 is 6. 3 times 3 is 9. You have to add 4 to each of those values to give you your function rule. So this would be your equation or your function rule. Now, this is important. This is probably new for you. Another way to write the function y equals 3x plus 4 is this way. F of x equals 3x plus 4. This is called function notation. Function notation is when you use f of x to indicate outputs. You once again read this as f of x. Or you can say f is a function of x. Now, almost all of your teachers you will hear say this will say f of x. Now, also you will hear g of x, h of x. those also indicate functions of x. Example number 3. Make a table for f of n equals negative 2n squared plus 7. Use the values 1, 2, 3, and 4 as the domain. Now, I want to make sure you understand that this is not f times n. You're not multiplying anything. This is f of n. It's just the name of a function. So if you made a table, I am sure that you have done this before, where it's called the t-table, where you normally do x and y. In this case, we are not using x and y. What you're going to be using is n, and your output's represented as f of n. So the n values we need to use are 1, 2, 3, and 4. Now for the most part, if you wanted to show work on this, you can. It should be easy. For example, if we plug in 1, you could plug in 1 and show the work if you want, but you know 1 squared. 1 squared is 1 times negative 2 is negative 2 plus 7 is 5. If you plugged in 2, 2 squared is 4 times 2 is negative 8 plus 7 is negative 1. If you did this even further, we would get negative 11 and negative 25. This is a table of values, otherwise known as a t-table, what you've called it in the past. These represent your domain. These represent your output, which is your range. Now, you can use a function rule and a given domain and range of the function. After computing the range values, write the values in order from least to greatest. So we're going to go on to our next example. Our final example. Evaluate the function rule f of a equals negative 3a plus 5 to find the range of the function for the domain negative 3, 1, and 4. So now when we plug these in, this is how you're going to write this. This may be new for you. We're going to say f of a equals negative 3a plus 5. The first number we're going to plug in for a is negative 3. So here's how it looks. F of negative 3 equals, and then you plug in negative 3 for a. So you'd write this as f of negative 3 is what? Well, negative 3 times negative 3 is 9, plus 5 is 14. If we plugged in f of 1, that gives us negative 3 times 1 plus 5. F of 1 would equal 2. And lastly, f of 4, and I would expect you to show no work on these. You guys are all bright enough that you can just plug it in. 4 times negative 3 is negative 12, plus 5 is negative 7. So f of 4 equals negative 7. But here's where it gets a little weird. Since the domain was given in a set, we have to write the range in the same. So after computing the range values, we have to write the value in the order of least to greatest. So you have to write the values in order from least to greatest. So right here, the range will be negative 7, 2, and 14. And we write that as a relation in this set.